Okay, let's visit your projectile motion. So here in this question, we've got a small ball is dropped from a height of 2 meters and it bounces a few times after it landed on a cement floor. Ignore air friction. The position time graph below is not drawn to scale, represent the motion of the ball. Okay, this is what we have here. Right, so now to define the term free fall. What are we talking about when we talk about free fall? So, free fall here, we're talking about the motion of an object. Okay, the motion of an object which is under gravity only. Okay, that's it. So here, free fall, let me just do this. Free fall, the motion of an object under the influence of gravitational force under the influence of gravity only. This only is very important. Okay, that is your free fall. So use your exam guidelines to answer all your definitions. Okay, now they're asking us here to use the graph and determine the time that the ball is in contact with the floor before the first bounce. Okay, the first bounce. So we can see that the ball moves from here. Let me use another color. Moves from here, gets here. Okay, and then from here, this time to this time, it's on the ground, or it's in contact with the ground, and then bounces off. Okay, so that means if you want to get the time it took the ball, or the time the ball spent in contact with the floor, we are going to have this. So we can just say delta t, maybe this time here, which is 0.67 minus the 0.64. Okay, minus 0.64, because this gap here is showing you that the ball is in contact with the ground at this point. Okay, this one here. Okay, that's the gap that is important. This is the contact time. Okay, so that means here then you're going to have what? You're going to have your 0.03 seconds. This is free 2 marks for you. And then the next question here, this is point 1. Gonna have 3.2.2. Then here they're asking us to determine the time it takes the ball to reach its maximum height after the first bounce. So it means they're asking you to calculate the time it took for the ball to move from here to here. So it means what are we looking for here? We're looking until this midpoint here. That's what we are looking for. Okay, so what does this mean? So it means we can check what is the time what time did it take the ball to move from this point until this point here, So that means what we're going to do again, we're going to say delta t equals to 1.9, okay, 1.90 minus your 0.67. Now note this is from the time it took from moved from here until here. But now to get to the maximum, which is the half, we can divide this by a 2, and then we're going to get the time. Okay, we're going to get the time. That's it. That will be your 0.62 seconds. That's the time it took just by using this, because they're saying use the graph to determine this, and that's what we are doing. And then we have the saying here the speed at which the ball leaves the floor after or at the first bounce. So that means you're looking at the velocity here. what is the velocity there? Okay, how do we then calculate it? Now, when you move here, we have VI, and then we're going to have VF here. VF here is going to be 0 in this case. Okay, so the velocity at the maximum is going to be 0. Even here it's going to be 0. This F is going to be 0. So it's always going to be 0. So now what do we have? We've got the time it took the ball to reach this height. We've got we are looking for your VI. So it means what I can do here, I can come back and say 3.2.3. I can say VI equals to, no, it's supposed to be VF. VF equals to VI plus A delta T. So I have the time it took to get to the maximum height. I have VF also, I just need VI. So VF is 0. VI is what I'm looking for. And then what is my A? Now my A in this case, I'm going to say it's minus 9.8 because I'm choosing down to be negative. Okay? And times my time is going to be 0.62. So VI is going to be, let's check. So VI you have 0.076, okay, meters per second, or you can round it off to 2 decimal, which is this, per second. This is your final answer. Right. And then let's see the last one. Determine time t indicated on the graph. So time t, this is time t. Now we need to then know or try to get to time t. What is time t? So there are things to note here that at time t, what is the height? The height is 1.2 meters. So that means I can say my change in y is 1.2 meters. Okay, as you can see from the graph. Then we need to find out what is this t here. Okay, so one route that we can take, we've got your change in y. Okay, and then we can try to calculate the initial velocity here that we can then use at a later stage. Okay, so we can say here VF squared equals to VI squared plus 2A delta Y. What are we going to use? We're going to use this as a starting point, which is your VI. Okay, VI. And as I said before, that your VF here is going to be 0. That's what we are considering at the moment. We are considering the movement from the bottom, which is your 0, until your 1.2 meters. So it means if I do that, I have to say 0 here. Say VI. I don't know what is VI at this point. So then 2 minus 9.8. Okay, 9.8, then times your height. Okay, times your height, which is 1.2 meters. Then from here, you're going to have your VI. So your VI squared is equals to, you have this. You can punch your calculator and then see what you get from there. Okay, actually once you've got this is going to become positive. It's going to be positive 9.8. Okay, and then VI is what? So from my answer, I'm getting 4.85. Okay, meters per second. This is what I have for my answer. Okay, now we are not done as yet because we are looking for time. So we can use another formula to then get what is time. Okay, what is time? For the time that is here, this t. How do we then go about this? Or which formula do you think we use? Okay, so the formula that I'm going to use here is this one, where I say VF is equals to VI plus a delta t. Okay, so why am I using this? Because we don't have VF, we only have VI here. Because in this case here, we're gonna have to use this and this point here, right? And then remember, when we have such a movement that is like so, usually what we have here, we have your VI, then here you're gonna have your VF. And then we know that your VF here is going to be minus VI. Okay, that's what the rules say. So that means here you're going to have your 4.85, and then in this point here you're going to have minus 4.85. This is your VF, this is going to be your VI. Okay, you can use this one. So that means you can say 4 minus 4.85 equals to 4.85 plus minus 9.8, then delta t. Now we're going to get the time it took to make this movement from here to here. That's the time we're going to get. And then from that time, we're going to come back and add it here. Okay, because this is a timeline. So you're going to get, it's more like we're going to get the difference that we're getting when we're doing these calculations here. Right? That's what you're going to get. So then we say, let's say it like so. We're gonna have minus 4.85 minus 4.85 equals to minus 9.8 delta t. That's what you're going to have. And then you can just divide both sides by minus 9.8. Minus 9.8. Okay? Then your delta t is going to be what? So for my delta t, I have 0.9898 seconds. Okay? You can already see for yourself that you've got your 0.9898, and which is greater, which is not greater than 1.97. So this is telling you that here we're talking about just a difference. Okay, we're talking about the time it took to move from this point then to get to this point here. So it means then what you then have to do is you say your final time is going to be your t is going to be your 1.97 plus 0.9898, and then you have your answer here. Let's punch in again and see what we get. Okay, so then you your answer as your 2.96 seconds. So that means t here is 2.96. Okay, that's it for this question here. Okay, coolies, let's meet on the next one.